Alright, so we will be doing question 8.7 now. Now, question 8.7 it is the return to the game with the two neighbors in problem 8.5. Okay, so again we have an average. We have an average benefit per hour for individual I doing the work on landscaping is given by 10 minus Li plus Lj divided by 2, where Li is the numbers of hours individual I is spending on landscaping, and Lj is the numbers of hours individual J spends on landscaping. Alright, so okay, so we have two players, player 1 and player 2. Right, so now first of all we would like to write out the objective function for player 1 first. Alright, so for player 1 he will try to maximize his objective function, which is equal to the total benefit minus the total cost. Alright, so now what is the total benefit for player 1? So alright, so player 1 will try to maximize the objective function by choosing the number of hours, which is L1, that player I would like to spend on landscaping. Now the total benefit is going to be equal to the total number of hours that player I would like to spend. Sorry, player 1 would like to spend on landscaping, multiplied by the average benefit per hour. Right, so it's 10 minus L1 plus L2 divided by 2. Alright, so this is the total benefit for individual for the player 1, and we would like to minus that from the total cost. So we would like to minus the total cost from that. Now total cost for player 1, the question telling you that player 1's opportunity cost is either 3 or 5. So we have two cases over here where player 1 can either have a low cost or a high cost. So there are two types of player 1. One type is the one who having a lower cost, and another type is player 1 having a higher cost. Alright, so alright, for player 1 we have two cases. Alright, so the first case is going to be the lower cost, which is the cost equal to 3. Alright, so that's going to be equal to 3, and the total cost is going to be the opportunity cost per hour multiplied by the total number of hours that player 1 would like to spend on landscaping. Alright, so this is the objective function for the low cost. Alright, now for the high cost, it's going to be exactly the same. So I'll say this is alright. Alright, so I'll say this is case 1. Alright. Okay, now for case 2 is for the high cost player 1. Now again, player 1 will still have to choose the number of hours he would like to spend on landscaping by maximizing the objective function, which is the total benefit, which is still the same. The number of hours he spent on landscaping multiplied by the average benefit per hour. Okay, and now the total cost is a bit different because the opportunity cost for a high cost player 1 is going to be equal to 5, and we again would like to multiply that by the total number of hours player 1 would like to spend on landscaping. Okay, so that's the objective function for high cost. Right, so here we have case 2. Right, so now we will be solving each of the cases. Alright, so we're doing case 1 first, where player 1 trying to maximize this. Right, so he'll be choosing L1. So again, so we will try to find a first order condition where we differentiate the objective function with respect to L1. We will have 10 minus 2L1 plus L2 divided by 2 minus 3, and that is equal to 0. Okay, so that is our first order condition. So therefore, rearranging, we will get L1 equal to 10 plus L2 divided by 2 minus 3, and everything divided by 2. Okay, sorry. Alright. Okay, so I'll simplify here. 10 minus 5 is 7. 7 divided by 2 is going to be 3.5, and plus L2 divided by 4. Alright, so this is the best response function for player 1, given that he is the low cost he is the low cost person. Right, so this is the best response function for low cost player 1. Best response for player 1 low cost. Okay, alright, so we continue to do that for case 2, where we are dealing with a high cost case. Again, we will still have to find the first order condition where we try to maximize the objective function by differentiating it and make it equal to 0. So again, we still get L minus 2L1 plus L2 divided by 2 and minus 5, and we would like to make that equal to 0. Therefore, if we rearrange it, we will get L1 equal to 10 plus L2 divided by 2 minus 5, and everything divided by 2. So if we simplify, we get 10 minus 5 equal to 5 divided by 2 will give us 2.5. L2 on 2 divided by 2, that will give us L2 on 4. Alright, so this is the best response function for player 1 of a high type. Okay, of a high cost. Alright, so I'll indicate this is L1 low cost and this is L1 high cost. Alright, so that is the best response function for L1 low cost, and that is the response function for player 1 high cost. Alright, so now we come to player 2. Again, player 2 is also trying to choose the number of hours he would like to spend on the landscaping in order to maximize his objective function. So he also chose the number L2 in order to maximize the total the net benefit, which is the total benefits minus the total cost. Now again, total benefit is going to be equal to the total number of hours he decides to spend on landscaping, multiplied by the average benefit per hour. That's going to be equal to 10 minus L2 plus L1 divided by 2. Okay, now this is the average benefit per hour for player 2. Okay, so therefore it has to be minus L2 plus L1 divided by 2. So the positions are actually reverse to whatever we deal with player 1 before. Right, so you just have to be a little bit careful when you write the average benefit for player 2 over here. So it's not going to be the same average benefit that we use for player 1. You will have to take into account the position of L1 and L2 over here in the function. Right? Okay, so this is the average benefit per hour for player 2. And multiply by the numbers of hours, which is L2, you get the total benefit. And I would like to minus the total cost, which is our opportunity cost for player 2 is 4. And I would like to multiply by L2, which is the total cost for player 2. Right? So for player 2, there's only one case because there isn't any low cost or high cost for player 2. Right, so again, we just have to solve this maximization problem, by finding the first order condition. So differentiate the objective function over here with respect to L2, make it equal to 0. I'll get 10 minus 2L2 minus L1 divided by 2 minus 4 equal to 0. And therefore, L2 is going to be equal to 10 plus L1 divided by 2 minus 4, everything divided by 2. Right, so 10 minus 4 is 6. 6 divided by 2 is 3. L1 on 2 divided by 2, that will give me L1 on 4. Alright, so this is the best response function of player 2. Alright, now remember, one thing important to notice over here is player 2 doesn't know about the private cost of player 1. Okay, so he doesn't know what is the cost of player 1, so he doesn't know whether the player 1 is a low cost or high cost. So his best response function is going to respond to the average. Okay, I don't know whether you are low type or you are high type. I would just respond by assuming that you are somewhere in the between, in the middle, right? So it's going to be, so the L1 over here that he's responding to is going to be the average of L1H and L1L, right? It's going to be the average of the L1 of the high type and L1 of the low type. Alright, so he doesn't know what type the consumer, the player 1 is going to be. Therefore, his response is going to be responding to an average of L1. Okay, so I don't know whether you are L1H or L1L. I will be just responding to the average. I assume that you are going to be in somewhere in the middle. Alright, so and L1 bar is going to be equal to L1 high plus L1 low divided by 2. Okay, so it's going to be the average of number of hours chosen by player 1 with the high cost and player 1 with the low cost. Alright, so okay, so we have basically 3 best response functions over here. This is the first one. Okay, so I'll say this is first one. This is the second one. Okay, and this is the last one. Okay, so I have 3 functions. I have 3 variables that I have to find, which is L2, L1H, and L1L. So I know that it's possible for me to find the values of those. All right. So I'll be just writing the 3 function again. So the first one is going to be the best response function for player 1, given that he is having a low cost. So it's going to be L1L equal to 3.5 plus L2 divided by 4. Okay. The second equation is the best response function for player 1, given that he is having a high cost, and that's going to be equal to 2.5 plus L2 divided by 4. And the third equation is the best response function for player 2, which is equal to 3 plus L1 bar divided by 4, where again L1 bar equal to L1H plus L1L divided by 2, which is the average between the numbers of hours chosen by the low cost and the high cost player 1. Okay, so I don't know whether you are low cost and you're going to be choosing this, or you are high cost and you're going to be choosing this. I will just respond to the average that I believe that is going to be the best representation of the numbers of hours you are going to choose, right? So we have 3 equations. We will just have to find the values for L2, L1H, and L1L. So what I would like to do over here is to alright, so to substitute L1H and L1L over here into the third equation. Okay, so I'll expand the third one first. So from 3, L2 going to be equal to 3 plus a quarter of L1 bar, which is L1L, L1 low, plus L1 high divided by 2, right? So that's going to be equal to 3 plus 1 on 8 L1 low plus L1 high. Okay, so now substitute. So I would like to substitute the first and the second equation into the third. What I am going to get is L2 equal to 3 plus 1/8. Now L1L is going to be equal to 3.5 plus L2 on 4, and L1 high is going to be equal to 2.5 plus L2 on 4. Alright, so this will just give me 3, 1 on 8. Now 3.5 plus 2.5 is 6, and L2 on 4 plus L2 on 4 is L2 on 2. So if I expand everything, I get 3 plus 6 on 8 will be 3 on 4 plus 1 on 16 L2, and that is just going to be equal to so 3 plus 3 on 4 is 15 on 4. Okay. Alright, so if I move 1 on 16 L2 to the left hand side, that will give me 15 on 16 L2 equal to 15 on 4, and therefore L2 is going to be equal to 4. Alright. Okay, so now finding the value, so having found the values of L2, I will just have to use that to substitute back into the first and the second equation to find L1H and L1L. Right? So substitute L2 equal to 4 into the first equation. I'll get L1 low equal to 3.5 plus 1 on 4 times 4, which is 1, so I get 4.5. And if I substitute that into the second equation, I'll get L1H equal to 2.5 plus 1 on 4 times 4, and that will just give me 3.5. Alright, so if player 1 is having a low cost, he's going to choose 4.5 hours of work to do. If he is having a high cost, he's going to spend 3.5 hours on landscaping, and player 2 is going to spend 4 hours. Alright, so that is our Bayesian-Nash equilibrium. Okay, so the Bayesian, okay, so the Bayesian Nash equilibrium it's going to be, okay, so alright, so the Bayesian Nash equilibrium is going to be player 1 alright, equal to 3.5, low equal to 2.5, and player 2 is going to be equal to 4. Alright. Okay, so part B of the question, asking you to indicate the Nash equilibrium on a best response function diagram. Okay, so what we want to do is to draw the best response functions on a diagram. So we know that we have 3 best response functions. Okay, so I would like to, okay, so it's basically the first, the second, and the third equations that we have in the previous case. Okay, so I will just write again. So equation 1 is the best response function of player 1 for given that he is having a low cost, and that is going to be L1 low equal to 3.5 plus a quarter of L2. Alright, so from the second equation, best response function for player 1 given that he's having a high cost is L1H equal to 2.5 plus a quarter L2. And from the third equation, the best response function for player 2 is L2 equal to 3 plus a quarter of L1 average. Okay, so we would like to draw that on a diagram. Okay, so we have a best response function over here. So I have a vertical axis, I have a horizontal axis. Alright, so on my vertical is going to be L2, and on my horizontal is going to be L1, and I have an origin over here. Okay, so I will be drawing the best response function for player 1 low cost first. So looking at the best response function of player 1 over here, then I get if L, so I just have to pick the 2 points on the horizontal and vertical axis and connect them together to get a line. So if L2 equal to 0, L1 equal to 3.5, okay, so I get 3.5 over here. And if L1 equal to 0, L2 is going to be equal to, alright, so I'll pick another point, say if L2 equal to 4, L1 is going to be equal to 4.5. Okay, so L2, I'll pick it equal to 4. So here. Okay, so I'll make it here. So this is say 1, 2, 3, and 4. Okay, so if L2 equal to 4, L1 is going to be equal to 4.5. So I'm going to have another point there. Right, so I'll make this one equal to 2. Okay, so I'll get rid of the 3.5 here. Alright, so I have 1 over here, I have 2 over here, I have 3 over here, and I just have 4 over here. Okay? Alright, so 3.5 somewhere over here, where I have the first point, where L2 equal to 0, L1 equal to 3.5. And if L2 equal to 4, L1 is going to be equal to 4.5. So I should have another point. Okay, so I'll try to extend my line a little bit. Okay. So this is L1 and 4.5 should be somewhere over here. So I connect it together, I get another point for my best response function for player 1 of low cost. Okay. I should need 2 points in order to connect the line together. Okay, and that's what I need. So I already have 1 point on the horizontal and another point is going to be here. Alright, so I just have to connect this point and this point over here. I'll get the best response function for player 1 of a low type. Alright, so I continue to do that for the best response function for player 1 of the high cost. So again, this is the function. So this is the equation. Okay. So with the function here, if L2 equal to 0, L1 equal to 2.5. So I have over here, which is 2.5. And if L2 equal to 4, L1 is going to be equal to 3.5. Alright, so okay, L2 equal to 4, L1 equal to 3.5. So I know that I just have to go up here. And I just have to have another point to connect the line together. Okay, so it's my second point. And if I connect the horizontal point with the point over here, I should get my best response function for player. Okay, so this is the best response function for player 1 of the high type. Alright, so now the last one is the best response function for player 2. And that is going to be L2 equal to 3 plus a quarter of L1. Okay, so alright, so if I make L1 equal to 0, L2 is going to be equal to 3, so I know I have 1 point over here. If I make L1 equal to 4, L2 is going to be equal to 4, so that is going to be this point over here in the middle. Alright, so if I use a line to connect this and this together, I will have another best response function for my second player. Okay, so this is the best response function for player 2. Alright, so I just want to indicate the Bayesian-Nash equilibrium on this diagram. Now, best response function of player 2 is going to be responding to L1 bar, which is the average between L1H and L1L. So it's E going to be responding to the line in between the best response function of player 1 of the low type and the player 1 of a high type. So if I draw another dot line over here in the middle, okay, so if I draw a straight line going from here to here, okay, and okay, so we just have to make a dot line over here to indicate that this is going to be the line between the best response function of player 1 of a high cost and the player 1 of a low cost, right? And the player 2 is going to respond to this dot line over here. Alright, so this is the best response function 1 bar, okay, which is the best response function, the average of the best response function of player 1 of the high cost and the best response function of player 1 of a low cost. And player 2 is going to respond to that. Alright, so the equilibrium is going to be at the point over here for player 2. So player 2 is going to respond to the average, and this point over here is going to be the equilibrium for player 2. So we know that player 2 is going to be choosing L2, say L2 star equal to 4 in equilibrium. Alright, and with that L2 star equal to 4, if we going back to the best response function for player 1 of a high type, we are going to get this point over here, and 3.5 is going to be the number of hours chosen by player 1 of a high cost. Okay, and if we are okay, so I use a line over here, all right, to connect this. Alright, and if we if player 2 is choosing 4, player 1 of a low cost is going to choose. So if we go back to so if we project that to the best response function of player 1 of the low cost, this is going to be the point that the low cost player 1 is going to choose. Alright, so 4.5 is going to be the number of hours chosen by player 1 of the low cost. Alright, so the 2 points over here is going to be the equilibrium, okay, where player 2 is going to choose L2 equal to 4 and player 1 going to choose 3.5 if they are having high cost and 4.5 if they are having a low cost. Alright, so I'll just put the red over here to indicate that. Alright. Okay, so Patsy asking you what type of player 1 would like to send a signal to player 2 to signal that he is going to signal his type, okay, to signal his cost. Which one is going to have an incentive to do that? So now the player 1 only have an incentive to send a truthful signal to player 2 if that brings him a higher payoff. Okay, so we would just have to examine whether that is player 1 of a low cost or player 1 of a high cost that will have an incentive to send a truthful signal to player 2. Right, so we deal with player 1 of a low cost first. Alright, so now under the case of no signal, which is basically player 2 can't tell whether you are low cost, whether player 1 is a low cost or a high cost. Then if that's the case, player 2 is going to choose L2 equal to 4, and player 1 of a low cost will just have to respond by choosing L1 equal to 4.5. Right, so if that's the case, the total benefit, sorry, the net benefit so the net benefit for player 1 of the low cost is going to be equal to, so if we just use the net benefit or the objective function of player 1 of the low cost in part A, then we get going to be equal to L1 of the low cost multiplied by the average benefit, which is 10 minus L1 low plus L2 divided by 2, and minus the total cost of player 1, which is of the player 1 of the low cost, which is 3 L1. Okay, so so L1 low is 4.5, 10 minus 4.5 plus 4 divided by 2 minus 3 times 4.5, and that is going to give you 20.25. Okay, so that's 10 minus 4.5 plus 2 times 4.5 minus 3 times 4.5. That's going to give you 20.25. Okay, now if player 1 decides to signal player 2 that he is a low cost person, okay, so he's sending a signal to player 2 to identify that he is a low cost person, then player 2 is going to alright, so player 2 is going to respond to the fact that player 1 is a low cost. So the best response function for player 2 is going to be L2 equal to 3 plus L1 low divided by 4. Okay, so now player 2 got a signal that player 1 is a low cost person. He is going to respond to that information. Okay, and the best response for player 1 is going to be L1 low equal to 3.5 plus L2 divided by 4. Okay, sorry, I just have to check that I got the right best response function for player 1. Okay, that's right. Okay, so we have two best response function. You'll be able to find the values of L1 and L2 in this case. Alright, so if I'm solving these two equations simultaneously, then I'll get alright, so if we substitute one into the other, I will get okay, so if I so I'll say this is okay, so I'll sub the second into the first, then I'll get L2 equal to 3 plus L1 divided by 4, which is a quarter of L1, and L1 is just equal to 3.5 plus L2 on 4. Okay, so if I expand everything, I get 3 plus 3.5 on 4 plus 1 on 16 L2, and that would just give me 15.5 on 4 plus 1 on 16 L2. Okay, therefore, if I move 1 on 16 L2 to the left hand side, I get 15 on 16 L2 equal to 15.5 on 4. And therefore, L2 is going to be equal to okay, so that's going to be equal to alright, 308 divided by 75. Okay, now knowing the values of L2, we will be able to find the values of L1 low by using the second equation over here. Alright, so L1 low is going to be equal to 3.5. Alright, so I'll do that here. Plus L2 divided by 4, okay, which is 308 on 75 and everything divided by 4. Okay, so that is going to be 679 on 150. Alright, so that is the values of L1 and L2. So we would just have to find the net benefit for player 1. Okay, so that's going to be equal to L1 again. It's going to be equal to L1 low, which is 679 on 150, multiplied by the average benefit, which is 10 minus 679 150 plus L2 divided by 2. So this is L2 308 on 75 and everything divided by 2. Okay, and minus the total cost. Now total cost, which is 3 times 679 divided by 150. Okay, so if you use a calculator, you get okay. That will give you 20.5. Okay. Alright, so if we compare the net benefit for player 1 under low type, here under the case of signal with the case of without signal, then we see that player 1 will have an incentive to signal player 2 that he is a low cost person, because by signaling he will be able to get a higher net benefit. Okay, so we compare this one, the net benefit under the case of no signal and the benefit under the case of signal. We see that the net benefit under the case of signal is higher. Therefore, player 1 will have incentive, okay, to signal his costs. Okay. Alright, so he will have an incentive to send a truthful signal to player 2 to indicate that he is a low cost person. Alright, so we're now going to do with player 1 of the high cost, okay, and see whether he's going to have an incentive to do the same thing as player 1 of the low cost. Alright, so again we will be doing exactly the same. Now with the case of no signal, we know that player 2 is going to choose 4, and player 1 of the high cost is going to be choosing 3.5. Okay, so the total, right, so the net benefit for player 1 under the case of high cost is going to be equal to 3.5 times the average benefit, which is 10 minus 3.5 plus 4 on 2, and minus the total cost of the high cost person, which is 5 times L1, which is 3.5. Okay, and if we use a calculator, we'll get that equal to 12.25. Okay, now we're going to do exactly the same like what we did for player 1 of the low cost. With so we're going to find the net benefit under the case of signal. Alright, so if player 1 is sending a signal to player 2, then the best response function for player 2 is going to be L2 equal to 3 plus L1 of a high cost divided by 4. Alright, so if player 2 knowing that player 1 is a high cost, he will be responding to that information. And the best response function for player 1 of the high cost is going to be L1 high equal to I just have to check the cost, the best response function again, which is 2.5 plus L2 divided by 4. Alright, so now by substitute one into the other, you will be able to find the values of L1 and L2. Alright, so that will be just exactly the same with what we did before. And you are going to get L1 equal, okay, so L1H is going to be equal to 52 on 15, and L2 is going to be equal to 58 on 50. Alright. Okay, so now we will be able to find the net benefit for player 1. Okay, if he is a high cost person, so it's going to be equal to L1H, which is 52 on 15 times the average benefit, which is 10 minus 52 on 15 plus 58 on 15 divided by 2, so that's going to be 30, and minus total cost, which is 5 times 52 on 15. Alright, and therefore the net benefit is going to be $12. Okay, so it's going to be 12.017. Alright, so if we compare the net benefit under the case of no signal, it's going to be 12.25, and if he's signaling that he is a high cost person, he will only get a net benefit of 12. Therefore, player 2 will have no incentive to, player 1 of a high cost will have no incentive to signal his costs. Alright, so player 1 with high costs will have no incentive, okay, to signal his costs. All right.